Hi guys, today we'll be taking notes on Math Notes page 10. So make sure that if you've been writing your page number that you have page 10. And we are taking notes on 3.3 and it's titled Adding and Subtracting Equations. Okay, so our driving question is, how can we use algebra tiles to add or subtract algebraic equations? But before we answer that question, I don't know if you guys have ever even used algebra tiles. So I'm going to draw them out, then I'll pause the video and you guys can draw them out and I'll explain what each tile represents. Okay, so here are the algebra tiles. Usually the long rectangular tile represents a variable, and if it's positive, if it has a plus sign inside, or if it's green or blue, that means it's positive. And if it's red, that represents a negative variable. And if you have a little square positive, over here, I'm looking over here. Let me get my cool pointer. Yeah, so if you have this blue box, that means that it's a positive number, so plus 1. And if you have this negative box that I accidentally erased right now, that's a negative constant. And then one positive variable and one negative variable cancel each other out, or one positive constant cancels out one negative constant. So these are constants. And then the rectangles represent variable. So I'm going to teach you guys how to model an example and how to solve an example using algebra tiles. So I'm going to go ahead and write it out and then I'll pause it. Actually, I just want to write the question and then we're going to draw the algebra tiles together. So the example says, model and solve the equation. So first of all, I notice that I have one variable. So I'm going to draw one variable and it's positive. And then I have 3 negative constants. So here's a negative constant, a negative constant, and a negative constant. And then I have, on the other side of the equal sign, and usually you put a line to just kind of divide the left side from the right side of the equal sign. I have 4 positives, constants. And yes, I do want you to draw this out. Okay, so the end goal when I'm done with everything is for me to have one variable and all the constants on the other side, whatever that looks like. That's the goal, to have a variable, just one variable, equal to constants. All our constants are on one side and one variable is on the other side. Okay, so in this case, I see that I have 3 negatives right here. 3 negative constants. And in order for me to get rid of those negative constants, I want to add to this section 3 positive constants, because 3 positive constants will cancel out those 3 negatives. So I'm going to go ahead and just come to the side, and I'm going to add 3 constants to this side. But the thing about equations is, what I do on one side, what I add to one side, I have to add to the other. So I'm going to also add 3 constants to the other side. And when I do that, one of these cancels out one of these. one of these cancels out one of these negative constants cancel out one of these positive constants. So I'm left with my variable. And remember, this down here was the goal. This is the goal. So I have one variable. I have half of my goal. And then now I have, let's count. 1, 2, 3, 4, 5, 6, 7. I have 7 constants. Now, I'm not going to sit there. Okay, fine. I'll sit here and I'll draw all these boxes. So I have 7 total. Okay, so now from this picture, I have x equals 7. And I'm done. And look, if we were solving this equation, x minus 3 equals 4. Why don't we plug in this? I found that x is equal to 7. This mystery number equals 7. So that must mean 7, let's plug it in, 7 minus 3. Is it 4? 7 minus 3? Yeah, 4 is equal to 4. Yay! We found the mystery number. We found what the variable represents. And the variable represents the number 7. So I'm going to give you two more examples, and I want you guys to draw them out and try to solve these on your own, okay? So your next example is z minus 6 equals 2. And then I want you guys to find p minus 7 equals negative 3. Go ahead and draw the algebra tiles and give yourself, you might need a little bit more room than I gave on my screen. But just try this one on your own, or if you need some help, let me know. All right, guys, so if you solve these and you used algebra tiles, you might have noticed a pattern. So instead of using algebra tiles to explain this, I'm going to use algebra. So I have a variable right here. My variable is the letter z. And I want to get z by itself. At the end, I want to get z equals some constant, some number. I want to figure out what z is supposed to be. So I noticed that this plus 6 is in the way. I can just think of what the opposite is of of minus 6. And the opposite of minus 6 or negative 6 is plus 6. And what I do on one side, I do to the other. So what I end up getting is negative 6 plus 6. Well, that cancels out. That's 0. Well, I can just bring the z down. I don't need to write 0. And now I just add 2 plus 6, and that's 8. If you drew algebra tiles the correct way, you would have gotten a variable, and then you would have gotten equals, and you would have gotten 8 squares if you did it correctly. Now the algebra tiles, I don't expect you to draw algebra tiles every time you see an equation. I just wanted you guys to understand the algebra. And a way to understand the algebra is to draw your visuals and draw your diagrams. Now let's try our second example. P minus 7 equals negative 3. Well, my variable is this p here, and I want to get it by itself. The way I get that by itself is, what is the opposite of minus 7? Plus 7. What I do on one side, I do to the other. This cancels, and I'm left with p equals, well, negative 3 plus 7. That's the same thing as saying you have 3 negatives and you have 7 positives. Guess what happens? This 0 pair cancels, this 0 pair cancels, this 0 pair cancels. This is what you have left over. 1, 2, 3, 4. So you found your mystery number. This is using algebra. This is how I learned it when I was in school. My teachers didn't teach me algebra tiles. I think algebra tiles would have helped me understand faster. But this is the way that ultimately has been taught for a long time. And that's the way that I'm showing you now. All right. Now what happens if you have another example? Let's say you have a variable, and I'm going to move my screen up. So let's say you have a variable and it's not on the left. Or it's not on the, it's not on the left, it's on the right. So if it looks like this, -5 equals n plus 2. Well, guys, it's no different. You still have a variable. You want to get it by itself, and your goal is to get n equals some number. Now, what's keeping n from being by itself? This plus 2. So what's the opposite of plus 2? -2. And what I do on one side, I do to the other. And then let's solve. +2 minus 2, that's 0. I'm left with n equals -5 minus 2. This right here, imagine that there's like an invisible plus sign right here. -5 plus -2, if you have 5 negatives, 1, 2, 3, 4, 5, and then you have 2 negatives, how many do you have altogether? None of them cancel. You have -7. So your answer is n is equal to -7. You can also write it like this, n equals -7, once you have an answer. Those are equivalent. Okay. You can also just do mental math. You can think about it. If I plug in -7 right here, -7 plus 2, that equals -5. So you solved it. Some of you might not even have to use algebra or algebra tiles. You might be able to do this in your head. On Monday, I'm going to give you guys 3 more types of examples. But this is all you need to know for your assignment tomorrow.